founder of Start Somewhere and the inventor of the twist blocks. And today I would like to guide you through our Excel template that we have created for you to find your optimal twist block concrete mix. So let's look at it. What does it come with? Basically, what we have in here is a table to insert the sieve line that you may have received ideally from your constant material supplier. All the cells where you can input data are marked in gray. All the other cells are calculated automatically. What we see then down here is a graph, and that is the most important part of it. So that graph has two thick curves in it, an upper one and a lower one. Yeah. And so what do these curves say? So basically we want to find with our mixes, aggregates, with our sand and our aggregates, we want to find a mix that somehow fits between those curves. And whether it's closer to the lower curve or closer to the upper curve has an influence. The lower curve basically works with more percentages of coarse aggregates, which makes your mix easier flow into the mold, gives it more viscosity. Versus the finish might not be as good, as smooth as if you go to the upper one. So the closer you go to the upper one, the more fine elements you will have, so the more smooth your finish of the concrete block will be. So why don't we go right away to the upper one? Well, the reason is the more fine parts in the concrete mix, the more cement you will need, so meaning the more costly your mix will be and the less eco-friendly your mix will be. So what we try in this exercise is to be as close as possible to the lower line and as close as necessary to the upper line. So for this now we have prepared an example file in here, so how it's supposed to be filled up. So I'm clicking on that tab and I'm looking at now here. So this is a sample mix that we got from a supplier in Cape Town, South Africa. And first of all, what you need to insert is the actual sieve sizes, which vary in many countries around the world. So this is now what works in South Africa, may be different in Asia or other countries of Africa. And what we have here is 2 sand samples. So what does it mean in here? So 100% of our sand samples fit through a 14 millimeter sieve. 100% even fit through a 10 millimeter sieve, and 97% fit through a 5 millimeter sieve. So meaning our biggest grain is definitely smaller than 10 millimeters, and so on. So 94 still fit to the next smaller size, and so on until the very finest sieve, so it's below a tenth of a millimeter, only 0.8% fit through it. And that's basically what we find down here in the graph. So here we see less than a tenth of a millimeter sizes shown in here. Here we see the percentages. So this is the grain size, and here we see the percentage that can fit through there. Yeah. So then we insert the same for our sand number 2 and for our coarse aggregates. And now we have enough database basically to start playing with a mix design. So what we see in here, we have again our gray cells where we can manipulate data and play with it. And we can see what we have in here is a 40 to 60% mix of sand 1 and coarse aggregates number 1. So let's see what happens if we, for example, and this is the red line now, the actual one, alternate that mix design, maybe go to a 50 and 50% mix, which could also be an idea, and we see, oh, we have increased the amount of fine aggregates, which actually results in even overstepping our curve here. Yeah? So let's assume, maybe let's try with 45% here. So we always, it must make up 100, yeah, that's clear. And sorry, not 95, but 55%. So again, we're coming to 100% total. And we see, okay, this could still be a good possible mix. Yeah. In some occasions, yeah, I mean, material is very different all around the world. You may have to overstep that line somewhere, but at least it gives you a good starting point for coming up with a reasonable mix. So now, if we were to do all of that from scratch, yeah, we can look at it again on the other side. I think it's good to go through that exercise one time. So we are here, left with a blank sheet. We need to put in here basically what we have received from the supplier, which sort of is the same percentages passing that we can find in here. And we can just, for the simplicity, copy paste it over there. And then again, let's go back and copy paste just our coarse aggregates over here. Yeah. And then we just give it a name. We call it sand. Oops, I'm not allowed to do that. So I have to call it sand 1 in here, and I call it coarse 1 in there. So you see it automatically translates here the data. And here we have 0% and 0%, so nothing's happening. So we typically, a good starting point for every mix is to start with 30% of sand and accordingly 70% of coarse aggregates. So that you see how the sieve line is automatically formed, and it's drawn in here. So what we have here is a resulting grading curve, yeah, which is basically this reads its data from there. So what we want to do now is to be able to experiment with a bunch of curves. We have now this table here that is still blank. What we can do is we can mark it here, those percentages that we're parsing, and we hit copy and paste it in here. And now we have to be careful to say only paste the values, right? Because then you see only the values are passing, not a formula. Cool. And now what we can say is here, select data and add data, clicking here. So we call this 30% sand, 70% coarse. We add values of the X row in this. This would be our percentages here. Hit enter. And we add values for the Y row, which is these ones. The percentages passing. And then we hit OK. And hit OK. And what it does, it creates automatically another line that we currently don't see because it's right underneath. It's called 30% sand, 70% coarse. And now what we can do is we can start playing, like for example, putting 40% in here, 60% in there. And we see now we can compare our two mixes, what it actually means, and like this bit by bit, you know, keep the history in here. We call it 30% sand, 70% oops, coarse, and that's it pretty much. Lastly, we can say hold on, we can just go here and say deselect, flatten or smoothen lines, and now we have the same kind of jumping graph as and the other one. But now for you to actually know what to put into your concrete mixer, yeah, that's all very theoretical now, but practically you need to know the actual sizes to weigh, which you find in the next tab, which is here. So this is a global value. How much cement do you want to put in per cubic meter of concrete? So that is, it doesn't have to do with how many blocks you do. This is just general assumption. So starting off with 220 is relatively safe, and a water cement ratio of 0.9. Yes, it is very high compared to normal concrete mixes. So we're using very little cement to make it still viscous enough. Yeah, and obviously the goal is also to get down as much as possible with the amount of concrete, with the amount of cement in here, because cement is what makes your block most expensive. Still, going below 200 kilogram per cubic meter is typically not a good idea, because you will not find a block that you can actually cast, most likely. Yeah. So, and the water cement ratio could be maximum 0.95. It shouldn't go to 1. Okay, so the basically the higher the value, the less cement you need in here, but still the higher the value here, the less stable your block will be. So your true density of aggregates is typically what you also get from your supplier. Just leave the default value if you don't have it. It's not that super deciding. But what you need to now do is to define how much fits in your concrete mixer. And that's all you need to do. So how many blocks do you want to mix at a time? And for example, what we have in here, we know one twist block is about 8 liters, 8 cubic decimeters of concrete mix. So what we do here is we provide 4 times 8 plus 1 liter as buffer, so 33 liters of mix in here. Let's say if you were to do 5 at a time, you would put you would make 8 times 5, that comes to 40, and then to be safe you would maybe do 41 liters. So now it gives you, okay, you have to use 9 kilograms cement. If you have your mix of 40-60, that's what you have to insert. If you go to 30 or 70, depending on what sieve line you have decided to go for, then this gives you the exact ratios and the total water that you have to add. And with this, you can make your test mix, cast your block. If it's too hard to fill it, you have to go closer to the lower sieve line. If it's like the finish of the block is not super nice, you have a lot of honeycombs and holes in it, then you have to go closer to the upper sieve line. Okay, so that is for a start. And of course, regarding the water, you also have to measure the water that is in the sand, which is what you find in our manual. Cool. So I hope you succeed in finding the best mix for you, and wish you a lot of fun with it.